Hello, honors pre-calculus students. Mr. Durango here with your last video in section 7.5 on parametric equations. And, well, this is my X number of take on this video because it was too long initially. And so I've left all my work up here to sort of make this a little shorter video. Hopefully you'll be able to understand it and I won't take up too much of your time. This particular example will give you a little more practice with the orientation, so the arrow directions, and also the speed of the parametric equation. So let's get right to it. The example asks us to use each parameter to write the parametric equations that can represent y equals x squared minus 4 and graph the equations showing the speed and the orientation. So I think the graphing part is not too difficult, right? The parametric equations, so here are the parameters. A, t is equal to x, and b, t is equal to x over 2. That's a 2. And if we use these parameters to write the equations, the parametric equations, we would always write those as x equals and y equals. And so if t is equal to x, then, well, x is equal to t, and y is equal to, and so we would replace, if x is equal to t, we'd put a t up here and get t squared minus 4. And so these would be the parametric equations for this parameter. And for the parameter t equals x over 2, we would do the same thing. We'd solve this equation for x, so we get x is equal to 2t, multiply both sides by 2. And if we put 2t up here in for x, then this would be 4t squared minus 4. And so here are the parametric equations for these two parameters. Now the graphing part's coming up, and we're all doing quite well on that. So I'm plotting the times from 0 to 2 seconds, or whatever the increment is. Could be hours or days or whatever, but let's say it's seconds. And so from 0 to 2 seconds, if we put 0 in here for t, x is equal to 0. If we put 0 in here for t, y is equal to negative 4. It's so forth and so on through both of these cases. And when we graph it, we see that the first one gives us this much of the parabola, and this one gives us this much of the parabola. So for the same amount of time, 2 seconds in both cases, the second case gave us a lot more of the parabola than the first case, and therefore the speed is greater in the second case than the first case. The orientation arrows are pointing in the direction that time increases. So at time t equals 0, I had this point. At time t equals 1, I had this point. And see, I'm creating the parabola from left to right, so my arrows point from left to right. The same with this one. At time 0, I'm down here. At time 1, I'm here. And at time 2, I'm way up here off the graph and even into the other graph, which is sort of sloppy, but I think you can see what I'm trying to show here. So hopefully that short video will be enough to get you through. So showing the speed, you would just write t equals 0, t equals 1, and t equals 2 here. The orientation is the direction of the arrows, and the parametric equations are circled here. So that's how you do this kind of problem. If you have any questions, don't hesitate to email me back. Take care. Bye-bye.